Welcome back to a new session of MOOC on Information Security. Substitution Techniques. This part presents an overview of substitution ciphers used in the past. These ciphers are one among the two categories available in the traditional symmetric key ciphers. With this module, learners will get a rudimentary knowledge to learn much complex modern ciphers, and the objectives of this module are to define the terms and concept of substitution ciphers, to define the categories of cryptanalysis, to discuss Cipher cipher, and to discuss monoalphabetic cipher. Substitution cipher. In substitution cipher, each and every alphabet or letter or simply symbol of the plain text or message is replaced or substituted with another alphabet or symbol. For example, the plain text or original message is hello and its cipher is as follows. Each letter of the original message is replaced with different letters of the same language. That is, if H is replaced with K, then other letters will be substituted as follows. E is substituted with H, L with O and O with R. Therefore, the ciphertext thus obtained is KHOR, K-H-O-O-R. In this case, the logic used to replace or substitute is that the sender has taken the third letter that comes after each original letter of the message in the domain of the language used. That is, if the language of the original message or plain text is English, then its ciphertext should also be in English. The substitution mechanism can be represented through the following notations. If P is the plain text or original message, then C can be EK of P, where C is known as ciphertext or encrypted message. E is the abbreviation of encryption and the subscript K is the key used for doing encryption. The term key will be discussed later. Decryption of the ciphertext is represented as P equal to DK of C, where P is the plain text, D means decryption, C is the ciphertext and K is the same key by which the encryption is carried out. Once the message is encrypted, it is known as ciphertext. The ciphertext will be sent to the other end of the communication, known as receiver or destination. At receiver's end, the cipher will be converted or decrypted to its original form so as to make it legible or intelligible. Cryptanalysis is a term usually comes with cryptography. Now, we will discuss the term cryptanalysis. Cryptanalysis. The art and science of creating secret code or encode ciphertext is known as cryptography, whereas the art and science of breaking or breaching the secret code is known as cryptanalysis. In fact, the counter attack to decrypt a ciphertext by a trespasser or intruder or an unauthorized person is called cryptanalysis. The person who does such act is called cryptanalyst. There are different ways to counter attack the secret code, and to study the logic of the same will help us to know and create strong and better ciphertext. The possible cryptanalysis techniques are ciphertext only, non-plain text, chosen plain text and chosen ciphertext. Ciphertext only attack. In this type of attack, the intruder has the access to some ciphertext only. She or he tries to find out the corresponding key and eventually the plain text. As per Kirchhoff's principle, it is assumed that the attacker knows the algorithm. With the known algorithm and the available ciphertext, the attacker can try to find out the key by virtue of the different methods described in the section below. In fact, this is the most probable type of attack and hence often used. Brute force. It is also known as exhaustive key search method. In this method, the intruder or attacker tries with all the possible keys. It is assumed that he or she knows the algorithm and the key domain with the ciphertext. He tries to decrypt the ciphertext with all the possible keys until plain text is apparent. The only way to prevent this type of attack is to enhance the size of the key domain up to a maximum extent. Statistical. Making use of the statistics or the general frequency or characteristics by which a letter comes in a text of the language used, intruders can guess at some extent the key used. For example, in English, the most frequently used letter is E, and with this knowledge, attacker guesses that the mostly used letter in the ciphertext is E, and so as other letters as well. Pattern. When aforementioned characteristics are hidden, people may try to find out the key analyzing the lexical relating to the word or vocabulary pattern of the text. Categories of substitution cipher. Two types of substitution ciphers are available. Monoalphabetic. Here, each character or letter of the plain text is replaced with single character or letter from the same language. That is very clear in the example described in the above section to encode the word hello. There, H is replaced with the letter K, E is replaced with H, and each L is replaced with the same letter O. Caesar cipher, multiplicative cipher, and affine ciphers are good examples for monoalphabetic cipher. The mathematical representation of this cipher is as shown below. C equal to P plus K mod N, where C is the ciphertext, P is the plain text, K is the cipher key, and N the number of letters available in the communicating language. Polyalphabetic. In contrast to the monoalphabetic cipher, here each letter or character of the plain text is replaced with different letters. Relationship between a symbol or a letter in plain text with a letter in ciphertext is one to many. Consider the same word hello used in the example of monoalphabetic substitution, and here the two letters L are replaced with two different letters from the same language. Auto key cipher, Playfair, and Virginia cipher are all belong to polyalphabetic cipher. For example, in auto key cipher, different keys are used to encode each letter of the original message, and that makes it polyalphabetic. Keys are generated out of the plain text characters. The following description illustrates the algorithm. Consider the word C, C-E-E, to encode. Initially, for the first letter of the plain text PT, a random key is selected, and keys for the remaining consecutive letters are determined by the plain text characters. First key K1 equal to 5, a random selection. Then the key for the second letter is determined from the alphabetical order or position of the first letter of the message, and key for the third letter is the value of the second letter, and so on. Therefore, the message C becomes XWI as shown below. S with the value 18, E with 4, and the next E also with 4. Random key 5, 18, 4. Here the keys are 5, 18, and 4, which becomes 23, 22, and 8, which represents X, W, and I. Hence, plain text C becomes the ciphertext XWI. Deciphering is done with the same algorithm. Caesar cipher, also known as additive cipher or shift cipher. It is known after the great Julius Caesar because he had elegantly used in it the history to communicate with his vanguards. He always used a key size 3 to substitute his plain text characters to make them confidential. For our ears, let us again consider the word hello to explain this algorithm. Here, the letter H is replaced with a letter which is 3 letters after H. The letter E is replaced with a letter that is 3 letters after E, and so on. The mathematical notation of this algorithm is shown below. Encryption: C equal to P plus K mod N, where as always C is the ciphertext, P is the plain text character, and K is the key, and N is the number of available letters in the domain language. In English, it is 26. Caesar often used 3 as his key. That is, in Caesar cipher, C equal to P plus 3 mod 26. Decryption will be P equal to C minus 3 mod 26. For example, plain text C becomes in ciphertext C equal to S plus 3 mod 26. Find the chronological order or positional order of letter S in English alphabetical order. That is equal to 18. Letters are counted from 0 onwards. So, the position of letter A is 0 for our reference. Therefore, the first letter S in plain text is substituted as shown below. C equal to 18 plus 3 mod 26, C equal to 21 mod 26, which is equal to 21. So, the letter at position 21 is our ciphertext corresponding to the letter S. Therefore, S is substituted with letter V, so as other letters. Hence, our ciphertext for the word C would be VHH. In this module, we have discussed the ciphertext with the substitution techniques. Hope this module gives an overview of the monoalphabetic and polyalphabetic ciphers. Hope this session was useful. See you next time. Bye.